Hey, welcome everybody to another jam session in the FP 101X functional programming course. And in this snippet, I'm going to show how the ideas that we learned in the main course with Haskell can be applied in .NET. And in order to program .NET, I'll be using Xamarin Studio. And Xamarin is an open source implementation of the .NET framework that is cross-platform. So if you want to write code in C# or Visual Basic or F#, I'll only do C# today, but Xamarin supports the other two languages as well. If you want to write cross-platform .NET code that runs on the iPhone, on Android, on Windows Phone, on the Mac, on Windows, Xamarin Studio is your tool of choice. And because of that, Xamarin Studio is also my tool of choice. But let's sit down, open up Xamarin Studio, and write some C# code using functions. And C# has a couple of interesting twists that we haven't seen in other languages. So here is our Xamarin Studio, and here is some sample C# code. As always, C# requires a main method. It doesn't require you to pass the arguments if you don't use them. And here's the typical hello world. Console write line hello world. And F here is our first example of a lambda expression. So the right-hand side here, x double arrow x times 2, is a lambda expression that multiplies the argument by 2, and I assign it to F. Here's another form of a lambda expression that defines a function from int to int h, and it takes a parameter x, and then it uses a statement body with curly braces. So those are the two forms of lambda expressions, and here I print f and h. Now, C# does support type inference, so I can write, var z equals 42. And when I do this, you see that it has inferred 42. The editor here says, this is redundant because I'm not using z anywhere. But what I wanted to show you is that you can define var here, and the compiler will infer that z has type int. Now you can ask yourself, why can't we use type inference here? So let's try to write a var here. And let's not forget the type. And there is our var. And let's run this code. And now what you see here is that it says an implicitly typed local variable declaration cannot be initialized with anonymous method. What does that all mean? Well, the thing here is that in C# I can use a lambda expression like we do below here. And now that's just gonna go away. Good. Here I define another lambda expression. It's exactly the same lambda expression as here, but instead of giving it the type a func from int to int, I say it's an expression of func from int to int. And this is a super interesting aspect of C#, where a lambda expression by itself has no type. That's why I couldn't use type inference there. But depending on the context where you use this lambda expression, that lambda expression can be turned into code, like here, into a function, or it can be turned into data, like here, into an expression. And the price you pay for that magic, where you can take a lambda expression and represent it as code and as data, is the fact that you have to kind of explicitly type them. But let's have a little look here at G and see what IntelliSense tells us. So what you see here now is that G has a body. So let's kind of get G's body, and then here we have all kind of methods on G. So for example, can reduce, etc. So this gives you a full API to manipulate this lambda expression as data, and this mechanism is used very heavily, for example, in frameworks like the entity framework, and in the olden days in Link to SQL, where you can take fragments like this, analyze them, and compile them to SQL. Satnam Singh at Microsoft Research has also done some interesting work here, for example, where he takes these lambda expressions and compiles them into FPGAs, and people do all kind of interesting things. And if you are a Lisp programmer, the way you would do this is using quoting, and this is kind of C#'s way of doing quoting using static types. Good. One thing that C# doesn't have, and which we saw in other languages that did work, for example, in Kotlin, in Scala, in Dart, is the idea of local functions. So you can have a lambda expression here, which is kind of a local function, but I cannot define a function or a method just like I defined here inside another method. So suppose I wanted to define h here that's nested inside main. You see already here that I get a syntax error that you cannot do this. And oh well, I've already defined h, so let's define this, call this k. But I still cannot do that because now it gives me a proper parse error saying that you cannot have local function declarations. So I think that's something that I do miss in C#, because now if you want to declare a method like that, you have to lift everything to the top level. What else can we say about C#? Well, comprehensions. So in C#, when I say here var x's equals new array 1, 2, 3, 4, 5. So here we have an array x's of the values 1, 3, 5. You see that's full type inference. I don't have to specify any types. And now I can say var y's equals from x in x's where x less than 4 select x times 2. Okay, and here you see the comprehension syntax in C#. It looks a little bit like SQL, and that's on purpose. So these are called link comprehensions, but they work exactly the same way as Haskell list comprehensions. Talking about comprehensions, C#, of course, also supports the range of higher order functions that we know and love from Haskell. So in this case, if we look at the inferred type for y's, that has type enumerable of int. And if we use IntelliSense to show the methods there that are available there, we see that there are a lot of methods in here. And C# calls them slightly different than Haskell and other languages. Instead of map, C# uses select, and the pop-up there is a little bit small, but select is the version of map, and it takes a function. Bind or flat map is called select many. If we look here, there's a select many, and instead of a filter, C# uses where. So except for this little alpha renaming of these methods, all the higher order functions over collections and even more, like group by, joins, are all available in the standard library. All right, so if you want to give C# or Visual Basic or F# a try, you can immediately apply all the things that you learned in the Haskell part of the course to programming in these .NET languages. Thank you, and see you next time.